Good evening, everybody. Today I am going to present a talk on estimation of variance of parameters in a model proposed to study the prognosis of lung cancer in the males. I am Manjula S. Delbanjan from Don Bosco Institute of Technology presenting this paper. The objective of my study is to fit a second degree equation and a cubic spline model to study the prognosis of lung cancer with respect to age. To test the goodness of fit model using the direct standardized cross-validation residual test. Also, we derive the variance of the parameters involved in this model. As we know that cancer is one of the major health problems persisting worldwide, the secondary data on the incidence rates of lung cancer is available in the National Cancer Registry program. The model 1 is fitted for incidence rates of lung cancer in males, mainly for the two regions, Bengaluru and Mumbai. And the model is designed for the two groups, group 1 and group 2. Here one polynomial is fitted for every group and the variance of parameters of second degree curve is derived. So as we know, the group 1 is defined here as the consisting of the young male adults in the age group who are aged between 20 and 60. In the age group 2, old male adults are there who are aged above 60 years of age. Let us denote the different notations in the age group 20 to 60, which we have named it as group 1, as L1IJ denotes the number of males suffering from lung cancer, N1IJ denote the population at risk, and lambda 1IJ denote the observed rate of incidence of the lung cancer. In group 2, let L2IJ denote the number of males suffering from lung cancer, N2IJ denote the population at risk, and lambda 2IJ denote the observed rate of incidence. Here, if Xij denotes age, then the estimate of incidence of lung cancer for males in the region I and the jth age class for different groups is given by the model 1. Now the people who are aged between less than 20, there is no data available as to such where they are suffering from lung cancer. So the rate of incidence of lung cancer in the age group who are aged between less than 20 years of age is 0. So we exclude this age group from our study. In the age group 20 to 60, by trial and error method, we fitted different models, but we found that lambda 1ij is equal to a1 xij square plus b1 xij plus c1 plus alpha 1 ij is found to be a good model which closely relates to the existing data. Similarly, when we saw in the age who are aged above 60 years of age, for those people, the rate of incidence of lung cancer is given by a cubic spline model as A2 x1ij cube plus B2 xij square and so on. We have fitted the cubic spline model. So as you know, whenever we fit a model for a given data, the parameters in the second degree are A1, B1, C1. In the cubic spline model, the parameters involved are A2, B2, C2 and D2. Here we can estimate the parameters involved in both group 1 and group 2 using the least squares method. And the residuals which are involved while fitting the model are alpha 1 ij and beta 2 ij. Both these are assumed to be normally distributed with mean 0 and variance sigma 1 ij. So in order to test whether the two models fitted for group 1 and group 2 are a good fit or not, we use the direct standardized cross-validation residual tests given by the two equation R1ij is equal to lambda 1ij minus expected value of lambda 1ij divided by square root of variance of lambda 1ij. Similarly, for group 2, the standardized cross validation residual test is given by R2ij. After the evaluation of both these residual tests, the residual tests are shown in the last column of the table 1 for group 1 in the Bengaluru region, and we observe that all these R11J values are less than 1.96. Similarly, for the group 2 of the Bengaluru region, R21J are all the values less than 1.96. Similarly, we can observe that R11J and R21J values are less than for the region Mumbai also, for group 1 as well as group 2, but the tabular representation of that we have presented in our paper. To illustrate the values of R11J and R21J, we have illustrated using the Bengaluru region only in this PowerPoint presentation. Also, in Bengaluru region, the observed and estimated rates of incidence of lung cancer are pictorially represented using these two graphs. In the age group 20 to 60, as we have fitted a parabolic curve or a second degree curve, the dotted line is the estimated curve and the smooth curve is the observed rate of incidence. In the first age group, that is group 1, from 20 to 60 years age, the persons who are aged above 60, as we have classified them under group 2, follow a cubic spline model. Here also the estimated rates are denoted by the dotted lines and the smooth curve is used to denote the observed rate of incidence. So as we have fitted a second degree equation for the group 1 model, which is of the form like we have fitted lambda 1ij. Instead, here in order to derive the parameters a1, b1, c1, it is equivalent to deriving the parameters or the variance of the parameters a, b and c. Okay, so in order to derive that, we shift the origin of the variable xi to xi minus x bar, and thus the small c changes to capital C, and because small c is also a constant, capital C is also constant, variance of capital C becomes equal to variance of small c. If variance of the variable yi, so yi are the set of values given to us, xi also are the set of values available to us. For the available values of xi and yi, we have to fit a new model in the form of parabola or second degree curve. During the fitting, we also make use of certain conventions. That is, let us substitute xi minus x bar as capital Xi, so that summation capital Xi will be 0. By property of the mean, sum of the deviations taken about mean is 0. Here also sum of the cube of the deviations taken about the mean is 0. Using these basic properties of the mean and also using the normal equations, we have derived the variance of B as a sigma square divided by summation capital Xi square. So as you know that capital Xi stands for small xi minus x bar, and variance of A is given by sigma square divided by summation xi square minus x bar square whole square, and variance of C is also derived using, that is, it is given by sigma square by n into bracket n minus summation xi square whole divided by summation I is equal to 1 to n capital Xi square minus x bar square whole square. So when we fitted the model 1 by observing the pattern of incidence rate of lung cancer in males, for group 1 the second degree fitted well. For the group 2, the cubic spline model had fitted well. We also estimated the parameters involved in both group 1 and group 2 using the least squares method. Last but not the least, we derived the expressions for the variance of parameters. Actually, we derived the variance of parameters of the second degree curve was derived. So during the process of fitting the model 1, the standardized cross-validation residuals in the last column of table 1, we found that all those values are less than 1.96 for both the regions. Thus, we can conclude that the second degree model fits well for group 1 in the Bengaluru region, not only in the Bengaluru region, in also in the region Mumbai, it fits well. For group 2, we observed that the values of all the standardized cross-validation residuals are less than 1.96. That is, we observed that in table 2. From table 2, we can conclude that the cubic spline model also fit well for both the regions for group 2. I thank you all very much for your patience listening, and thank you.